three-phase AC to DC applications, you have the three-phase rectifier capacitor filter circuit. It is very similar to the single-phase rectifier capacitor filter circuit, except that we need to add one more arm to account for all the three phases. Now let us take the sources, three sources, VA, VB, VC. They are star connected in this fashion, the neutral. And these three line voltages, you bring it out and let us connect it to the diode bridge. Now you have a three-phase diode bridge, one for each phase, and connect the phases in this manner. Then output of the diode rectifier, you connect the capacitor and then the load resistor. So this is A, B, C. This will be VA, VB, VC, let us say, measured in this fashion. This is V0 and I. Except for the addition of this extra diode bridge and three-phase supply, the rest remains the same. Let us look at the waveforms of this current and the output voltage to understand the three-phase rectifier capacitor filter operation. Let us now draw the waveforms for the three supply voltages and see how the ripple voltage waveform at the output would look like for a three-phase rectifier capacitor filter circuit. Now let us draw the XY axis, the X axis is T, and let us now draw the three-phase waveforms. I will draw in this fashion. You will know that three-phase waveform drawing is difficult, but doing it this way will make it much simpler. Yes, now this is the A, B, C, A, B, C, so on. And now when it passes through the rectifier at this node, across this node, if capacitor were not there, you will see that this will rectifier fold. This will be rectified waveform, fold back. So I will show that in dotted. So you will see that these will get rectified. This bottom portions will get rectified in this fashion. And then look at this envelope. This is the envelope that you would see here, and this envelope you obtain even without the C filter. So this would give you 13.3% ripple. Now this, if I zoom, I should be able to, I'll take this as the reference 0, and then with respect to that I will zoom this, and the output wave shape will be something like that. Similar concept, you have in steady state at this point, let us say the diode conducts, the output voltage tracks the input envelope, and then discharges. Then at this point tracks the input envelope, and then once the input envelope goes below the output, diodes are reverse biased, then the capacitor discharges, so on, this continues. Now this would be the conduction times whenever they track the input envelope, and if you draw the verticals, you will see the current wave shapes will look something like that. The current wave shape, this current wave shape is at this point.